Good day, welcome to One-on-One Maths Private Tutors. Today, we start on this topic on estimation. What is estimation? Estimation is a rough calculation of the value, number, quantity, or extent of something. So estimation is not a guess, it is a rough calculation. Where is estimation used in the real world? There are professionals called quantity surveyors whose job is to estimate the cost of materials and labor necessary for projects such as construction. So it is a very important tool, and these are the basics of a profession. Even budgets for a country or a company or a project are estimated using estimation methods. So we start with estimating lengths. To estimate lengths, compare with measurements you know. Let's look at this example. Estimate the height of the lamp post. So there is a man standing under the lamp post, and we can use the average height of a man, which is 1.75 meters or 175 centimeters. Now we look at how many lengths of a human being can fit in the post. So we have this length, which is the second length. So this is the first length. If we say this is 175 centimeters, this is also 175 centimeters. This is 175. We can also take another length up there. So that is 3 lengths now. And we can see it's approximately 4 lengths of a human being, about 4. So this will be 175 by 4, which will give us 7 meters or 700 centimeters, which will give us 700 centimeters, which is 7 meters. Anything from 6.5 to 8.5 meters, depending on the height you choose for the men under the post, will do. Let's look at this. Estimate the height of the fence. So we have a man there and about half his length. So we can estimate this to be 175 centimeters multiplied by 1.5 or 1.5, which will give us 262.5 centimeters, which is approximately 260 centimeters or 2.6 meters. So this is a good estimate. Remember, there is no correct answer for estimation, but it has to be reasonable. The length of the fence. So we have this man. We can use the height of this man. We say we have 1, 2, 3 times the height of the man. So it's an estimate. So we can say 3 times 175, which will give us 525 centimeters, which is approximately 5 meters. Remember, this is an estimate. We have calculated and we have said it's 3 times, but we can see there's this small extension. So we can estimate it down even to 5 meters. Make sure that you include the units with your answer and that they are sensible. For example, the length of a motorway should be in kilometers, not meters. So if you are calculating the length of a road, kilometers are a better way to calculate than meters. When estimating, do not try to be accurate. What is wanted is a rough estimate. Now we come to rounding off. Rounding to a given number of decimal places. First, we have to find the digit in the decimal place to be rounded to. Look at the next digit or the digit to the right. If it is less than 5, leave the decimal as it is. If it is 5 or more, round the decimal up by 1. Let's look at this example. Write each of these numbers correct to 2 decimal places. So we have 9.368. So the decimal place we are interested in is the second decimal place, which is 6 here. So we look the number next to it, which is this 8 here. Is 8 greater or equal to 5? If it is more than 5, round up the decimal by 1. So 8 is more than 5, so we increase this by 1. So now it becomes 9.368. 0.37. DP, it means decimal places. Let's look at B, 0.0438. The second decimal place is the second number after the decimal comma. So we go 1, 2. So we are interested in 4. Then we look the number to the right, which is 3. 3 is less than 5. So we leave the decimal as it is. So now we can say this is equal to 0.04 to 2 decimal places. This number is less than 5. So this remains as it is. Let's look at C. 84.655. Now, we are interested in the second decimal place, which is the second number after the decimal comma, which is 1, 2. This here is what we are interested in. So we look at this number next to it. Is it 5 or more? If it is 5 or more, round the decimal up by 1. So we have to increase this by 1, which will give us 84.66 to 2 decimal places. Rounding to a given number of significant figures. How do significant figures differ from decimal places? Significant figures are counted from left to right, starting from the first non-zero digit. The technique is the same as if we are rounding, except the significant figure part. For decimal places, we are counting the number of digits we want after the decimal comma. But for significant figures, we are counting from left to right. From the first non-zero number, if we have 0.0438, and if we say we want to 2 decimal places, we are counting 2 numbers after the comma. That's what we want the limit to be. But for significant numbers, if we say 2 significant numbers, we are starting from left to right. And starting at the first non-zero number, we want 2 values. So our limit should be there. That is the difference between decimal places and significant figures. So let's look at this number. This is the first significant figure. 5 is the first significant figure. 3 is the second significant figure. 4 is the third. 6 is the fourth. This 0 is the fifth. This 0 here is the sixth. And that 0 is the seventh significant figure. So after we have our first significant figure there, everything after that becomes significant. What do we mean? If we have 0.405809, this 0 is not significant, this first 0. This is our first significant figure. This is our second significant figure. This is our third significant figure. This is our fourth significant figure. And this is our fifth significant figure. And this one is our sixth significant figure. So these zeros, this 0 and that 0 after the first significant figure are also significant figures. Even if you are given a fraction 0.321, starting from left to right, we don't count 0. Our first significant figure is 3, our second is 2, and our third is 1. These are our significant figures. First non-zero from left to right. So if we are asked to round off to, let's say this one, 0.312 to 2 significant figures, you look at the first digit that is not required. Okay, so we want to round it up to the second significant figure, which is this one. And we look at this one, which is not required. If it is greater than 5, we increase this one. If it is less than 5, it remains as it is. So this will be equal to 0.32, since 1 is less than 5. To round off this to 2 significant figures, this is the first, we want to round it off to this to 3. We will look at the next figure that is not required. Is it greater than 5? No, it is less than 5. So this remains. So we have 5,300,000. That is to two significant figures. SF will mean significant figures. Let's look at this example. Round 52,617 to two significant figures. So we want to see the first and the second significant figure. So we look at the third significant figure and use it to round off. 6. We ask ourselves, is this value greater or equal to 5? Yes, 6 is greater or equal to 5. So 2 will increase by 1. So we now have 5, 3, and then the rest becomes zeros. So 53,000. That is to two significant figures. Round 0.072618 to three significant figures. So 1, 2, 3, 6 is the third significant figure. Now we work with the next number, which is 1. Is 1 greater or equal to 5? No, it is less than 5. When it is less than 5, this number will remain. So this will be 0.0726. That is to three significant figures. Round 17,082 to three significant figures. So which one is the third significant figure? This is the first, second, and the 0 is our third significant figure. Now we look at the number next to it, which is 8. Is 8 greater or equal to 5? Yes, therefore we increase 0 by 1, which will give us 17,100. That is to three significant figures. Always state the accuracy of your answer when you have rounded them. This is important. State it. Two significant figures, three significant figures, three significant figures. Or even decimal places if you are doing decimal places. Okay, let's look at these examples. Write each of these numbers to one significant figure. So first we look at the first significant figure. We consider the number next to it, which is 1. 1 is less than 5. So this remains as it is. So it becomes 5,000. B, 5.817. To one significant figure, we consider this 8. 8 is greater than 5, so we increase this by 1. So this becomes 6. 0.04715. This is the first significant figure. 4. Now we consider the number next to it. 7 is greater than 5, so this increases by 1. So this becomes 0.05. So we must always state one significant figure. One significant figure. Always state your accuracy. One significant figure. For this, the first significant figure is 1. We consider the number next to it, which is 4. 4 is less than 5. So this remains as it is. So it becomes 100,000. So one significant figure. For E, 1 is the significant figure we want. So we consider the number next to it. 9 is greater than 5. So we increase 1 by 1, which will give us 2,000. Our accuracy is one significant figure. Thank you.